All right, today we're going to be working on something called dimensional analysis. This is also known as the factor label method. So we're going to be learning how to do unit conversions a very specific way. And this is going to be a method that we use throughout the year for different types of problems. All right, often you are required to solve a problem with mixed units or to convert from one set of units to another. And dimensional analysis is a way to do this. Now, this requires two quantities that are equal to each other, and we call that relationship between two quantities an equality. So for example, if A is equal to B, then I know that A divided by B is equal to 1, and B divided by A is equal to 1. And we can use this in order to do our unit conversions. So if I take an actual, units that are equal to each other, so 1 minute is equal to 60 seconds, 1 minute divided by 60 seconds would be equal to 1, and 60 seconds divided by 1 minute would be equal to 1. So this here, draw that on there, is one of my equalities. And you can see that I can either use the 1 minute over 60 seconds or the 60 seconds over 1 minute. Both of those are equal to 1, which allows me to use this as a unit conversion. So again, there's going to be various equalities that allow us to do this. Today we're just starting with being given a list of equalities and being able to use our given list. In our following lesson, we'll get into how we can actually set up some of these equalities using our chemistry reference tables. The other thing you want to keep in mind is that if I were to give you this and ask you to solve this on your own, you would be able to do so based on the fact that you know that if something is in both the numerator and denominator, you can cross it out. So those 3's could get crossed out in order to solve that. Same thing with units. The biggest idea here is that we want to be able to set up our units so that we can do that and we can cross out our units. So we could cross out our centimeters, cross out our meters, and be left with a sole unit of kilometers in this case. So keep that in mind. That's going to be a big trend as we're going through these. All right, example number 1 is dealing with volume, so I put those equalities up at the top. This says how many pints are in 1.75 liters. And again, you could probably figure out and solve this on your own, but the goal here is to learn how to solve this using dimensional analysis. So the very first thing you're going to do, if I can get the pen on here, is you're going to start with whatever you are given. So we're given 1.75 liters. All right, we're going to set this up using sometimes called like train tracks, railroad tracks. Okay, we're not going to put anything below it. Okay, we're just putting our 1.75 liters to start. All right, now what's going to come next is going to be our first equality, and we're going to end up in this case using 2, so I'm just going to split that line. So in this section here, I have to have two values that are equal to each other. Okay, if I start with liters, I have to put liters in the bottom. So when I look up here, there's a couple different ways you could always solve these. Excuse me. I'm going to look to be using my 1 liter in quarts. And by getting to quarts, I can then relate to pints, which is what I'm trying to get to. All right, so how do we actually go about plugging in these two equalities? Because I start with liters, I'm going to start with my equality that has liters. This 1 liter is going into the bottom, not because of the 1, but because of the liters. Because by doing so, and I'm going to go ahead and write then what this is equal to, which is the 1.057 quarts. By placing this here, I can cross out my liters, just like we saw on the previous slide. And if I were to stop here, my answer would be in quarts. But I don't want it in quarts, I want it in pints. So this is where we put our second equality. Do I put the 1 quart or 2 pints in the bottom? It's all based on what I have in the numerator right now. So since I have quarts up here, I have to put my 1 quart down here. And again, it's not because of the 1 that this is getting placed here, it's because of the quarts. 1 quart is equal to 2 pints. Okay, these quarts get crossed out, so I'm left with pints, which is what I want. So that means I can stop setting this up. And then I know then that my answer is going to be in pints. And then I'm going to be doing 1.75 times 1.057 times 2 divided by anything on the bottom. So you multiply across the top, divide by anything on the bottom. And when you do that, excuse me, you get 3.70. Okay, if I have 3 sig figs to start, I round my answer to 3 sig figs. You don't base your sig figs off of the conversion factors. And that would be my final answer. All right, so now we're going to do how many yards is equivalent to 260 centimeters. All right, remember, you always start with what you're given. So I have 260, include that decimal because that's important to your sig figs, centimeters. Okay, I'm going to extend that over. We don't put that over anything, we just leave that blank. All right, again, there's a couple of different ways that you can go about using these units and relating them together. I'm going to choose to go from centimeters to inches, this one here, excuse me, 1 foot to 12 inches. And then I'll use that 1 foot in order to go from 1 yard to 3 feet. So I'm actually going to use 3 different equalities or conversion factors in this setup. Now, which one do I put first? Well, if I'm starting with centimeters, I have to have centimeters in the bottom. So I'm going to use my conversion factor equality that goes from centimeters to inches. So I'm going to have my centimeters, which goes along with a 2.54 centimeters, which is equal to 1 inch. All right, so I can see my centimeters cross out there. Okay, remember, the two values that go above and below each other have to be equal to each other in order for this to work. Now that my answer is now that my number is in inches, I now can go to feet. So I need to put, if I have inches up above, I need to put 12 inches down below. So I can put my inches down there, and that's equal to 1 foot. Okay, these inches cross out. Now I'm in feet. I want to get to yards. So now I'm going to use my last conversion factor, which is that 3 feet is equal to 1 yard, which is what I'm looking for. My feet cross out, and now I'm left with yards. So again, whatever is my final thing that's left not crossed out, that's my unit for my answer. Okay, we multiply everything across the top, divide by everything across the bottom. Be very careful how you set this up in your calculator, making sure you're paying attention to the order of operations. And if you do that correctly, you should get 2.84 yards. And again, I rounded this because my answer started off in 3 sig figs. So, or I'm sorry, my given value was in 3 sig figs, so my answer is in 3 sig figs. All right, one last one for this video. This one's a little bit more complicated. We have a couple extra units going on. We're going to be converting 80 miles per hour to meters per second. So this one's going to take up some space, so definitely start over to the left. All right, we're going to have 80 miles. In this case, because I have miles per hour, I actually am going to place something below, because 80 miles occurs in 1 hour. All right, so I'm first just going to deal with the miles. You want to do these in pieces. So I'm going to ignore the 1 hour. I'm going to leave it there. But I'm going to start to convert this miles to meters. So how I'm going to do that, and again, there's a couple different ways you could do this. You wouldn't have to do it the same exact conversion factors or equalities as I am. But I'm going to use the relationship between miles and kilometers. And then I'm going to use the relationship between kilometers and meters to get there. So I'm starting with miles up above. I want to get rid of that, so I have to put my 0.6214 miles down below in the denominator, and then that's equal to 1 kilometer. Okay, my miles can then cross out, which is great. Excuse me. I now can go from kilometers to meters. Okay, 1 kilometer is equal to 1,000 meters. Okay, these kilometers cross out, so now I'm left with meters, which is what I want in my numerator. All right, now we're going to deal with the hours. So let me just grab a different pen color just so you can see this just a little bit better. Let's see, we'll go to red. All right, now I'm going to deal with this 1 hour over here. All right, we're going to use the same type of principles that we've been using. I'm going to use equalities, so I'm going to use time values that are equal to each other. And if I'm starting with hours in the bottom, I have to start with hours up here. So I'm going to place 1 hour up here. 1 hour is equal to 60 minutes. Okay, so now my hours can cross out. And then I want to go all the way to seconds. I have minutes in the bottom, so I can then go with minutes up above. I know that 1 minute is equal to 60 seconds. And then minutes cross out. Okay, so then when I get to my final answer, the only unit that's left up in the numerator is meters. And then the only unit that's left in the bottom is seconds. Okay, that matches what I was trying to get to. And then if I go ahead using my calculator, multiply everything across the top, divide by everything across the bottom, and I round to, remember, if I start with 3 sig figs, I end with 3 sig figs. So you should get an answer of 35.8 meters per second. Obviously, this example number 3 is a little bit trickier, but again, if you can follow those basic principles of how to set up these equalities and looking to cancel out units, you'll be in pretty good shape for tomorrow's class. All right, you guys are all set.